Hello everyone, welcome to Code Kamkaji. I hope everybody are doing good. In this video, we are going to discuss about introduction of complete CI/CD pipeline, and we are going to discuss about what kind of stacks and what kind of technologies that we are going to use for this entire completion of our CI/CD pipeline. So stay tuned till this video, and if you haven't liked, share, subscribe to Code Kamkaji, I request you to go and do it right away. So I brought some stacks and the terminologies that we are going to use in this entire complete CI/CD pipeline. So the first, we are going to use the source code management. So in the source code management, we are going to use GitLab, and for CI/CD, we are going to use GitLab itself. And for React is our source code, so where we are going to write this simple application. And hello, welcome, whatever it is. So I will show you in this continuous video. And for STAT, which we call as a static application security testing, that we are going to use Sonarqube for code quality and code coverage, and Semgrep for finding the code vulnerabilities. And for SCA, security composition analysis, we are going to use a tool called as a Trivy. So Trivy is going to find the security vulnerabilities of your open source modules and libraries. And containerization tool that we are going to use a Docker, and image scanning, again we are going to use a Trivy. And the orchestration, we are going to use a Kubernetes as a deployment, and we are going to run our container of the Docker into a Kubernetes cluster instead of the pod. And GitOps tool that we are going to use ArgoCD, and for DAST we are going to use AWS XApp. So these are all the stacks and these are terminologies that we are going to use as a complete package of a CI/CD pipeline. And in this video, we are going to discuss about each and individual importance of each terminology and why we need to use it. And we are going to discuss about how our source code management and looks like, what is our source code, how does it follow structure look like, and what all components that we are going to integrate it, like a Kubernetes manifest file and Docker file and Nginx configuration files, and even our source code of your React. And we are going to discuss about everything detailedly in this video. And do not skip it, watch it carefully if you'd like to go with or if you'd like to learn bunch of things about the productionized or real world best practices of DevOps. So I would like to highly recommend you to watch it completely. And at the end of this video, you are going to get full knowledge of how you can create any CI/CD pipeline, irrespective of stack. It can be Java, it can be any other a stack. So I strongly recommend you to go and watch it completely. And if you have any queries, I request you to drop your comments in comment section. And I'm going to attach the tools and technologies and whatever files that I have referred and documentation, everything I'm going to add into this video description. And by following this video, you first going to step into what is a prerequisite for this entire CI/CD pipeline. Later you will discuss about what is the source code management and how our React application looks like. And later you will be discussing about how you can create and integrate the GitLab runner. And at the end, you are going to enable all these terminologies as a CI/CD pipeline by making a stages and jobs. So let's jump into the concept of practicality and how we can integrate and how we can create all this CI/CD pipeline.
Okay, so we had discussed about the tools that we are going to use for this entire CI/CD pipeline. Now it's time to discuss about complete architecture of CI/CD pipeline. So I brought a large diagram of infrastructure which has written in a PDF file, and I'll attach this PDF file into the GitHub so you can go through it. So this is the complete CI/CD pipeline and stages and jobs, and I will be explaining you from the beginning, what exactly happens in complete DevOps principles. So stay tuned. So here we have three people. I can say that three teams. So developers team and DevOps team and testing team. Let me zoom in a little bit. You guys can see perfectly. So what these guys do, they do push their source code into any source code management. It can be GitLab, it can be GitHub, it can be Azure repos, it can be AWS code commit, whatever it may be. So our requirement, being a DevOps engineer or operational engineer or DevSecOps engineer or MLOps engineer, that we would like to create a CI/CD pipeline from that source code management. So that's what, for this demo, for this entire explanation, I am going to use GitLab as a source code management and GitLab for the entire CI/CD pipeline. So if I step into the CI/CD pipeline jobs and stages, so I'll show you like in this session itself, like how we can write the pipeline as a code, which we called as a we write in YAML syntax pipeline as a code, and the file extension is dot gitlab -c.yaml file. So in that, we are going to add stages, and in that stages we are going to use those stages for jobs. So if I take a look into that, imagine in the organization you may work on compile language, you may work on interpreter language. So based on the languages or based on the stacks, you can either have the maybe one or two jobs more, or you can have the lesser two or more jobs in your architecture diagram. But the principle, the flow is same for all the ci pipeline. Here at the first stage I have added in this architectural diagram called as a install. So if you are using any compile language, so it's your responsibility to install all the dependencies of this stack. It can be Java, it can be .NET, or it can be React, or it can be Python on your target runner. So you might have added a target runner to your GitLab. So you need to install all the dependencies like supported versions of your stack and other dependencies. So this is the first stage called as install. So what this stage will do, under the stage we have one job called as install dependencies. So it will enable all the dependency installation on the runners to execute your next stage. So the next stage we have the stage called as a build. If it is a compile language like a Java, you may use a project management tool as a Maven. So with that you can compile your source code. You can create the artifact like jar var ER extensions. If it is interpreted language, so you can directly go to the stage testing after initializing your dependencies. So we have discussed successfully about the install stage and the build stage that we have seen like two jobs. The under the install stage we have the install dependencies, and the build stage we have the compile code job. And the next stage into our CI/CD pipeline called as a stage test. So under this stage we have the few jobs. The first job is unit test. So what is happening, this job will go and test all your test cases into your source code which was written by your developer. And for that we need to add one stage, one job for this, so it's called as unit test. And the second job in the stage test called as scanning your code quality and code coverage. For that we are going to use a Sonarqube. So we can integrate the Sonarqube into your Sonar Scanner CLI into your runner. So the Sonar Scanner CLI will go and scan your source code, and will give a code quality and code coverage. I mean, it will scan your code vulnerabilities. So there's the another job under stage test. And the next job we have the Semgrep. So Semgrep is a tool of CLI which will scan all your source code, and it will give you the first party vulnerabilities, which means whatever code you have written, it will scan your source code, and it will give a result of how many vulnerabilities are there, the code that you have written and you kept in your source code management called as a GitLab. And the next job under the stage called as a third party vulnerability scanning, we called as a security or software composition analysis. For that we are going to use a Trivy. So Trivy is a tool that it will go and scan all your source code and for finding the third party vulnerabilities such as dependencies of open source modules, libraries, and all the open source related stuff. And the next job under the same stage called as a malware scan. So this scan, we are going to use a ClamAV. So ClamAV is a tool that it will go and it will scan you all the files for viruses, malwares, and trojans into your in a source code. So that's what under the stage we have these many scanners that we won't let any vulnerability, any security flaws are going for into the deployment. And the next, if you are using a container based deployment, so we are going to have the Docker build and scan. If you are using a container package based deployment, so we may need to package your source code. So for that, we have already written the Docker file, and we kept regularly into the source code management. So here, we are going to use a Docker file to create the Docker image. For that we are going to create a new separate job to build a Docker image we call as a Docker build or Docker image build. So this stage will create the Docker image out of the Docker file, and the next job inside of same stage called as a Docker image scan. So this is going to use a Trivy as a tool. It will scan your entire image with your with the tool that you have installed called as a Trivy, and it will give you all the reports of your Docker image vulnerability. So that's how you can prevent all the security issues even on your Docker image. So once the Docker image build and Docker image scan gets some completed, so we are going to push the Docker image into the image registry that we called as a Docker hub. So this is where we have another stage for pushing your image into a Docker image registry. So for that, we have the job under this image push registry. The job name called as a Docker image push to Docker hub. And the next, once it got pushed, so here we have the next stage called as a deploy. So we are going to deploy this image as a container instead of a Kubernetes cluster. And for that, we have the dedicated Kubernetes cluster, and on that Kubernetes cluster we have installed one tool called as ArgoCD. So what this tool will do, it will pull the image from your image registry, and it will pull the all the manifest file that you have kept into our source code management. So it will pull both, and it will get sync and it will get deployed into your Kubernetes cluster. So this is how you can get to know that the deployment has succeeded. And this is the Argo CD, is a continuous deployment and delivery tool that you can use it for CLI, and you can connect this tool into your GitLab runner, into your Kubernetes cluster. So you can pull all the manifest file from your source code management, and you can get applied into your Kubernetes cluster. And you can use rolling updates, rollbacks, and you can use canary deployments, so whatnot. You can use a number of deployment strategies with Argo CD. So once the deployment has succeeded into Kubernetes cluster, so we are going to check the health checks, whatever service that we have exposed. It can be node port or it can be load balancer. So we are going to take that URL or IP address. So we are going to add that as a separate stage for checking the health checks of that particular IP address. So in that we have the job name called as a check deploy health. So this job regularly will go and it will hit the URL, and it will find the HTTP response. It can be 200 okay, or 300 reduction, or 400 or 500 client or server side errors. So accordingly it will let the pipeline go for next stage. So the reason why we have integrated this health check, because we would like to know how our pipeline check and how the deployment has happened, whether it is succeeded deployment or failure deployment. We would like to know via CI/CD pipeline. So once it is succeeded, at the end we have the scanner called as a DAST. In a short, in that stage we called as a DAST scanner. So the full form of DAST scan is called as a dynamic application security testing. So with this scan, what we are going to do, we are going to scan our application which is live in a respected environment. It can be non-prod or testing or production. So we are going to find, is there any vulnerabilities are present in a running application. So that's why we are going to use OWS AP JAP as a data scan, and we will scan the entire our application with that OWS AP JAP, and we'll find the report, how many possible vulnerabilities are there. It can be medium, it can be higher, it can be low. So all those things we are going to get into the data scan. So this is typical CI/CD pipeline architectural diagram, for any organization. If you take any organization, so it can be a similar, you are going to build your application, you're going to test it, you're going to create a Docker image, and you're going to deploy it into, it can be a Kubernetes deployment, or it can be a single server deployment, and later you're going to enable the data scanning and all, so this is the best way you can integrate, this is how you can integrate DevOps and DevSecOps in between it. Security is everywhere, and you can make sure that your entire application is stay away from vulnerabilities by following this all the stages and the jobs. So these are all the stages and jobs that you are going to run in GitLab. You can use any you can use Azure DevOps, you can use a GitHub Action. So CI/CD tool can be different, but the entire pipeline flow is similar for all the CI/CD tools. So I hope it is make you sense and understand about the entire architectural diagram of a CI/CD. So let's jump into the practical implementation of this architectural diagram. We can see more detail about it, and if you still have any questions about it, so I request you to drop your comments in comment section. Okay, so now let's discuss about the CI/CD pipeline prerequisites to enable the entire this flow. So I have brought the few prerequisites to follow it, and if you have this all prerequisites, so you can easily enable a CI/CD pipeline. The first one is a GitLab account. So you are going to use GitLab for source code management and the CI/CD. And the second one is you should have a source code instead of a GitLab. In the source code, you should have a stack code. If you're using Java, if you're using Python, so you should have a stack code related to that. And you should have a Docker file since you are containerizing your application. So you should have a Docker file, and you should have a Kubernetes manifest file that where you can get replicate those Kubernetes files into your Kubernetes cluster, and accordingly we are going to create the number of pods as per your desired values, and Kubernetes is going to take care about everything. And the next one is like you should have a GitLab runner configured. If it can be a single runner, or it can be group runner based on your project and project requirement. But in this session, we are going to use a single runner. So you should have a GitLab runner configuration, and it should be registered with your account. And the next one is AWS account for runner. So since you are going to register your GitLab runner, so you should have one VM, or so that's why we are going to take the virtual machine on AWS. So you can go to the AWS or Azure or GCP anywhere. So you just have to have one server, and we can configure that server into your GitLab. And here we are going to take the Ubuntu as a flavor of Linux for adding the runner. And the next one is a basic understanding of .gitlab c.yaml file. So you should have to have like basic understanding how the variables and stages and jobs get configured and get attached and get depends on each one of jobs. And the next one is Sonarqube cloud account. Since we are going to use a Sonarqube for code quality and code coverage, so you should have to have that account, and you should have to have Sonar Scanner installed on your runner. And Semgrep for SAST, static application security testing. So you should have to have installed this Semgrep on your runner. And Trivy for like scanning your third-party vulnerabilities and image vulnerabilities. So we have to install that on our GitLab runner. And ClamAV for scanning the vulnerability, scanning the malwares and trojans and viruses. So we should have to install this tool on your GitLab runner. And Docker installation, it should be mandatory if you're going with the containerization. And you should have to have a Docker Hub account to push your images over there. And you should have a Kubernetes cluster created. So you can go with AWS EKS or ACR AKS or GKE. So in my case, I'm going to take the Kubernetes cluster in Google Cloud. And you need to install ArgoCD server on the K8 machine. You need to expose it to access it via CLI and UI. And this is how you can map all the Kubernetes cluster manifest files into your Kubernetes cluster from your source code management. And you need to install OWS API app for data scanning to scan your source code. So this installation has to happen on your GitLab right now. So these are the basic prerequisites to initialize and successfully run your CI/CD pipeline on this series. So if you still have any doubts, I request you to drop your comments in comment section. Okay, so before building the enter your source code or creating the CI/CD pipeline for your source code, it's important to understand your source code folder structure and what files are resides into your source code management. So if you take a look into that, I brought the sample source code which was written in a React, and it contains several directories. So first I will explain you the code related directories, and after that I'll explain you the DevOps or infrastructure related folder structure and files. So here we have the one public directory related to React. So this folder is contain static files, and these static files directly serve to your browser and which are related to index.html and your static images and manifest.json and any other files. So it's this directory has going to be have all your public and static folders which are related and main important to your React application. So if I go to the next directory, which is src, so this where your entire React source code resides, like app.css and .js files where you have written your logic, like what you would like to print on your browser. So here I have mentioned that hi, welcome. This is a simple text, I have mentioned. But if you're working in a real-time project, you may have a number of text or a number of content that would like to bring into your browser. So that's where app.js files, and even if you'd like to test your source code, you can use that app.test.js file to test your source code. And it will have styles like css and crs and index.js. And so it may have a number of extensions which are more related to your code. And this is the folder is the heart of your project, very important thing where you like to write your content that you would like to print on your browser, and how you'd like to create your application, or web application or something. So this is about the SRC, and the next source code related component file called as Nginx configuration file. So this file is more related to configuration of Nginx, because we are going to use a Docker based image as Nginx. That's why, like, I have mentioned the configuration of Nginx, which port you would like to use it, and locations of your HTML files and all. So this is basic information about the configuration of your Nginx file. And the next one is the more important package hyphen log.json. So this files, like, it's going to log the exact version of your every installed package, and every installed version of your source code. It's going to lock it, and it's very important to lock your current version of your entire packages and source code. And the next one is a package hyphen package.json file. So these files contain the entire information, dependencies, versions of your project. So on the other hand, we can say that this is a blueprint of your entire project, like dependencies, script, and dev dependencies and whatnot. So you can keep all your source code informations which you can use to build your project. So this is where, like, it recites all the information, like name of it and version, scripts, and browser leads and development, like, you can keep a number of dependencies related information over here into the package.json, and you can find this package.json file into every, like, React application. And the next one is, like, these all the source code related components. And when it comes to infrastructure or DevOps or DevSecOps related components are Kubernetes and .gitlab c.yaml file, and always git ignore also, and Docker file. So these all, like, files related to our infrastructure. So file I'll explain you Docker and Kubernetes, and the end I'll go with the GitLab c.yaml file. So this is a Docker file, like, where we are going to create a image out of it, and because we are going to containerize our application. So this is a very basic Docker file components, which are, like, from the base operating image and work directory, where we are going to keep all our content, where we would like to run our script over there. And we're just copying this the content from our local to the image, and we are exposing our content with the port number 80, and we are going to use the command to uh, run the container. So nginx-g daemon. So this is the command where we can use to run our container. So this is a very basic component. Even it is not much complicated kind of thing. You can easily understand it if you have a minimal information about Docker file components. And the next one in the Kubernetes, so I have written deployment.yaml file and service.yaml file, that I can use this manifest file to expose and deploy my Docker container inside of my Kubernetes cluster into my Kubernetes pod. So the first one is deployment.yaml file. So it's very basic, like a YAML file. I'm using the version of my API, and the object type is deployment. This is the name of my deployment, and very basic information about my replicas of my pod, like, what all my label and what all my app label, and very basic things, sorry, match label and labels of my pod. And this section is related to my container. So what is the container name and where my images resides, so how would like to pull it, and what port do I need to use to expose the particular, like, container. So this is a very basic information about the deployment.yaml file. And the next one is a service.yaml file. Like, here I have been using API version is V1, similar to the previous one. And the object name is a service. And this is my metadata of my service. This is service name and annotations. And in the under specification, I have mentioned how I would like to expose our service. So here I have exposed as a load balancer, and the selector of my deployment. So this is a selector which is going to take for app, and the port I have used as a TCP, and the expose is 80, and the target port is 80. So it's up to you recommend how would like to expose it based on the protocols, and based on the port number, would like to expose it from internal and external. Okay, so I hope it is make you clear understand about the Kubernetes manifest file, which is very simple. Like, if you have basic knowledge on Kubernetes, you can easily understand it. And now it's time to understand pipeline as a code. So I have written the entire pipeline as a code in .gitlab-c.yaml file into our GitLab CI. So I have followed the best practices of our entire GitLab c.yaml file. So here I have brought the few stages, as we already discussed, for the entire React application build. So these all the stages can be similar to any other application or stack if you're taking, but maybe few stages may get added or maybe removed based on the stack that you are using it. Either it can be interpret language or it can be compile language. So if you see this one, I have the stages called as install, build, test, image build, and image push, deploy, and dash the scan. So as already we have discussed about these all the stages and what are tools that we are going to use it. And now let's jump into the jobs that are going to use under this stage. So the first job is install dependencies. This job is under install stage, and this is just installing all the dependencies like npm install, and it is going to give a path of it and cache. And this is the job is running on tags called as a CI/CD. And the next one, here we have the another job which is a code build. So we are going to productionize our code. So for that, this job is under build stage, and we're just passing some commands of React. And this is where our build artifact is going to be added, and it will be available over this path. And if you'd like to run this job, so our needs, this there is we have the job dependencies. So if I would like to run this code build, I need to see my pipeline has to be succeeded install dependencies, then only it will come for code build. Until unless this job got succeeded, this job won't triggered and this job won't execute. So that's the beauty of needs. And the next one is tag cycle. Here this job is enter running on CSAD tag runner. And the next one is unit test. So from here, it is running on the stage called as a test, and this is my job name, and I'm running my unit test with the script. And I'm copying the I'm creating the coverage file over here, icover.info. And this is the need. So again, this is the job dependencies of code build, and I have been using the tags of CICD, my runner tag. And the next one is a sonar check, where I'm going to check the code quality and code coverage. So this is a very basic information about the variables, and here it is the job name, and this is a stage name. And I might have added some sensitive information, but this is not the best practices. So if you're a beginner, so you can use this hard coding into the variable section of your job local. But as for the best practices, you can use Archika Vault or any key vault where you can store your sensitive information and you can retrieve it. And this is the basic catchy path. And here I have been calling all the variables into the script section, and I've been enabling all the sonar scanner is going to be enabled and scan it and push into the respected host URL, and now we can see the report. And if we'd like to run this entire sonar scanner, so I need the job dependency. So unit test job has to be succeeded and executed. And now we have the tag. So this is where we are calling our docker runner, and it get executed. The next we have the job called as a SAST, which is a static application security testing. Here we have been using a Semgrep as a tool, and the job name is Semgrep scan, and this job under the stage of test. And here we have been passing the Semgrep script that it will go and execute towards our source code, and it will file the code vulnerabilities, and it will give the report into the semgrep-result.txt, and you can see the Semgrep result into your web logs also. And this is depends on the Sonar Cloud check job, and for job dependency, and it is running on CACD tag. And the next one we have the dependency check, where we have using Trivy to scan our source code third party vulnerabilities that we regularly import the open source modules and libraries. So for that, we have been um, running Trivy scan to scan our source code. This is the command that we are using, and this is the stage it's under the job, and this is the report will generated if you run our source code. And this is depends on Semgrep scan. So if it Semgrep can succeeded, then it will come for the next stage. And this is the tags of our docker runner of our GitLab. And the next one, I will edit it. So this is just a mistake I have added. So but yeah, this job, what it will do, it will scan your entire file systems, and it will go and it will find your um, file malwares or malwares or viruses and trojans in your source code. For that, I'm using the ClamAV, and this is a job name, and this is a test under the stage, and this is the artifact path. Once the scanner has succeeded, it will go and publish the report over here. And this is the job dependency of dependency check, and this is the where I'm specify the image tag. This is the very basic things, if you're minimal knowledge of DevSecOps, what exactly do we need to use it, so you can easily sync up it, even though we have already discussed about all these scans, use cases. And now it's time to build the Docker image, since we are containerizing our image. So that's why I have integrated the another job called as image build, and this job is under image build stage, and these are all the variables related to the image of the building. And this is a script I use to build my Docker image. and this is the job dependency, and this is where I have specified the tag of my image. So this is exactly command like I used to build the Docker image, and I've just passed it some npm commands for testing purpose, and we can take advantage of this job, and we can create the Docker image out of your Docker file that we have already discussed. So once the image got built, so our responsibility to scan the image and to find the vulnerability. So that's where I have created another job. The job name is image scan, and this is the stage of image build. And this is a script that we are using to scan our images. So currently it is scanning the only one image. But if you have added in stuff here, if you have added dot, it will scan all your images instead of your runner. Or if you'd like to specifically scan the respected tagged image, so you can take advantage of this command. And this is where it is running on the GitLab runner, and this is depend on the image build job. So now one is the image push. Once you have built image, so your responsibility to keep the image secure in somewhere. Whenever you would like to pull the image, you can pull it. So that's where you need to push that image into any image registry. So for that, I have added the image registry job. So here the job name is image push, and this is the stage of image push, and this is the basic variable of my Docker repository. And here I have been passing the script. You may can see the some sensitive information, but it's not recommended to hard code it. Again, you can go with the best practices, but I would like to make more clear and easy understanding, so that's why I kept it as hard coded. And this is where tags of my Docker runner, and this is depends on the image scan job. And now it's time to deploy your image. So since we are using ArgoCD, which is continuous deployment and delivery tool, and here we have the job called as a deploy with ArgoCD into the Kubernetes cluster. And this is a stage name, and this is the very basic script that we can use as a ArgoCD CLI to initiate interact with the Kubernetes cluster. And here we have the ArgoCD login with the URL, and you can this ArgoCD has already aligned with the project or application that we have created over here. So this application has already aligned with our Kubernetes cluster, and this Argo CD is running inside of a Kubernetes cluster. So it will go and deploy your all your manifest files like deployment and service files into the Kubernetes cluster. So if you see this one, this is the manual, because I would like to do a continuous delivery, and I don't want to automatically deploy it. So that's why I just keep it as a manual. So until and unless I'll go and click the play button, so it won't get deployed. And now it's the tags I have specified the runner tag name, and this is the depend on image push. And the last job is dash the scan, which is dynamic application security testing. So once deployment is done, so I have specified the job name as a dash the scan, and this is the stage of data scan. And this is a script which is executing, and here I have specified my application URL where I have deployed it in the above. So once I have specified this application URL, so what dash scan will do, it will go here we have used AWS API Zap. So it will go and it will scan towards this IP address, whichever deployment you have done. So if that find any vulnerability, so it will give the report over this path. So you can take this part as a HTML. You can see how many vulnerabilities are there in your application which is currently running. And this is the tags of CI/CD, and this is depends on the deploy with ArgoCD. So job dependencies are up to you. If you'd like to make it, you can create it, or you can go with rules allow failure true or false. So just to I don't want to do messed up, if any one job got succeeded or failed, other jobs to be triggered. So that's why if you have enable a job dependency, so it will go and check the previous job if it succeeded, then it will get executed with another job. So these all the information about the .gitlab c.yaml file, and I hope you have enjoyed this explanation, and it makes you understand it. So all the source code, what we are exactly using in towards our deployments, and what exactly source code we are using, what exactly our DevOps or DevSecOps files and folders that we are using. So so now we are going to do this entire thing as a practicalities. We are going to call our each stage by stage, and we execute stage by stage, and we'll do the deployment into the Kubernetes cluster. So now let's discuss about the practical implementation of this entire theoretical discussion. Okay, so we have discussed about the folder structure of the entire React application, including the DevOps supported files like Kubernetes, Docker, and GitLab CI/YAML file. Now it's time to understand and discuss about the major component that registering a runner to your GitLab registry. So for that, you should have one virtual machine, or you should have one physical machine which is up and running. It can be in your on premises or it can be cloud. So in my case, I have been using AWS Cloud. So there I have taken one virtual machine. So this is my virtual machine, and the type of virtual machine is T2 medium of EC2, and this is the IP address, and this is the private IP address. Anyway, I'll delete it, so you don't need to worry about the privacy. But yeah, so this is where I have given the name of my runner as a GitLab runner, and I'm going to use this server to register as a runner to this my GitLab repository. So then only we can run our all the CI/CD pipeline, right? So you should have one runner or multiple runners. It can be group runner or it can be individual project individual runner to be added into your CI/CD pipeline. Then only you can run your all the pipelines via automation. So to do this interactivity, so we should have to create the tags of our GitLab runner, and we should have to use the token for authentication in between our GitLab and the server that we have taken into the AWS. So let's do this activity first. Let's register the runner into a GitLab repository, and then we can go to the practical implementation of each uh, job under the stage. So to do that, I'm going to the settings section and I'm going to the CI/CD. So here I'm going to the runner section to register the runner, and I'm going on the new project runner. So if I click on this, so I'm going to add a new project. The tag of my runner is a CI/CD, and I can give any configuration optional details or how I would like to make my runner. It can be stop stage or protected or lock for current project, and maximum timeout. How many minutes would you like to let this job or runs on this particular runner, and after that it will be get terminated. So you can give all those information while you're configuring this runner. So it's optional. You can make it as complicated if you want, or if you don't want to do it, so just place on create runner. So it will give you the options which operating system that you are using, either it is a Linux, Mac OS, Windows, and a Google Cloud Engine or Google Cloud or Docker or Kubernetes. So accordingly you can take the actions to configure the runner. So in our entire series, we are going to use the one independent Ubuntu machine. So for that, we're going to use this command GitLab runner register. But hold on, so we just have got the one command. But if I go to my server and if I do any uh, GitLab hyphen runner hyphen version, so it will throw an error because there is no supported packages has installed on this specific runner. So that's the reason, we should have to install the supported packages on this runner. So for that, I brought one documentation here. So we are going to follow this documentation one by one step. So we are going to install all the supported packages of GitLab runner. So first, I'm going to update the server of all the latest packages. So once it is done, I'm going to install the curl. So because we are going to hit one URL and we are going to get some uh, dependencies of our GitLab runner, and this is where we are going to call the respected URL, and we're going to get all the dependencies get installed or downloaded into our server. So once it has downloaded, now we are going to um, use one command to install our GitLab runner. So for that, we can pass this command. So the installation, download has been done for all the respected packages of our GitLab. And if I go to this particular URL, I can see the script over here. So all the shell script that have resides inside of this file, so those has been get downloaded. Now it's time to pass the command sudo apt install GitLab runner. So I'm going to pass it. So it's going to install all the supported packages on our server related to GitLab runner. So hopefully it's take time some time to install this respected command. So I'll pause this video and I'll get back to you once it is succeeded. Okay, so the package has been installed successfully, and now it's time to verify the package. So for that, we can use this command GitLab hyphen runner hyphen hyphen version. I'll clear the screen, and if I come here, if I do paste, so now we have successfully installed the GitLab version. So 17.1.10.1. This is the version of it. Now we can head back to our GitLab repository and we can use the same command that we have seen recently to register the runner. So we are going to use this command that we can register the server as a runner to our GitLab repository. So now I'm going to copy this command and I'll head back to the server, and I'm pasting this entire command. So we're just registering the URL with the gitlab.com, and this is the token. So now we are using the token based connection between our server to your GitLab repository. If I press enter, it's going to ask you like, what is the GitLab instance URL. I can say that this is the default one. I can give this default as it is. And now it is going to ask you the name of your runner. I can say that CICD is the name of my runner. So we can use this runner here. Now it's going to ask you the executor type, like which executor type would like to use it. So you can use Docker, you can use Docker Flash machine, you can use Kubernetes, you can use SSH, you can use a shell. So in this series we are going to use a shell executor. So for that I'm going to just press enter as a shell. Now it has successfully added, and even if you head back to the GitLab repository under this section, it shows that you have registered a new runner with a congratulations emoji. And if I pass this command in my server, it states that the connection has been established, and it is going to initialize the executor provider. If you have run any builds in your GitLab runner. So this is how you can initiate and you can register the runner at your GitLab repository, and you can confirm it going to the settings and CI/CD, and you need to go to the runner section. Here you can see that this is the tag of my runner, and if I click on it, this one, and it will show you all the details. What was the last time connected, and what is the configuration details. And if I go to the show details, I can see the system ID and whether it is online or ideal state and version of my GitLab runner that has installed. And this is the public IP address of my server that have taken in my AWS account. If I match it, this is the public IP address which is matching with the GitLab repository as IP address of runner. And executor is a cell, and this is the processor information and architecture information. And 29 seconds ago, it got connected, and this was the lost contact. So this is how you can register the runner to your GitLab repository to enable the pipeline jobs on this specific runner via shell executor. Now let's heads to the practical implementation of running each step from on each stage as a job, so we can see all the pipeline automation and we can finish off this. So let's jump into the practical implementation. Okay, so now let's enable one by one stages under the jobs. So if you see here, we have install, build, test, image push, deploy, and dash scan. So these are all the stages we have, and under the stages we will have the different jobs. So first, what I'm going to do, I'm going to enable these two jobs, which is a build and install, and later we can enable for test, and after that we can enable for image build and image push, and later we can see for deploy and dash scan. So now I'm going to enable the two jobs under these stages called as install and build. So I'm going to edit that into Web IDE, and I have already configured the runner for this project. So if you haven't followed me, so I request you to go and watch the just recent discussion about the installation of runner. Yeah. So I'm going to enable these two jobs. So I'm going to disable. I'm going to comment it out all the script of YAML. So rest of the script we don't need it right now. So I'm just committing out, and I'll go all the way to the top. So I'm going to initialize the dependencies first under the install stage, and this is my job name, and installation is done. And once this is done, it's going to build our code. Fine. So for see this one, we have the needs of install dependencies, and so install dependencies is independent now. So this is the first job, it's get enabled, and once it is done, so if you would like to go to the next job called as code build, so now this job is depends on the install dependencies of this job. So these jobs runs on sequential order. So if you have kept your job in a sequential, so it will get executed in a sequential. So what I'm going to do, I'm going to just comment it out over here, committing it to my source repository. So I'll go head back to the pipelines. So pipeline has been enabled, and install dependency job has been started running. So based on your runner speeds get enabled, and it's automatically actively done its job with the function manager. So this job has successfully done, and let's go and see the build job. So code build job has been started. Okay, so this job has successfully finished and it has created the artifact. So if I go to the browse, and I can see the artifact in build section, and if I go inside of this, I can see the statics and index.html, all the pngs and JSON files. So this is how you can initialize or install the dependencies on a runner, and you can build your source code of React. So now let's jump into the testing stage. So we have discussed successfully about the build, and now let's go with the testing stage. So in this testing stage, we have the different tools we have integrated, such as Sonarqube we have integrated, and we have integrated Semgrep, and we have used the Trivy, and we have used the this one Semgrep, and we have used the Trivy and for dependency check, and we have used the malware scan for ClamAV. So now I'm going to enable all these jobs, and and I'm going to make it call for entire test stage. So under this test stage, we have these many jobs. First one will get executed of unit test. It will test all the unit tests, and it will build the coverage of lcow.info file and the sonar check. So it will get checked with the Sonarqube code quality and code coverage, and Semgrep will get finding the vulnerabilities of your code. It will get initialized and it will give the all the results. And dependency check, it will run with a Trivy scanner, and ClamAV for finding the vulnerabilities in your source code. So this is how it's get executed, sequential order. And if you want to execute these also, we need to install this one Sonarqube Sonarqube scanner over into our runner, GitLab runner, and we need to install the Semgrep scanner into our runner, and we need to install the Trivia, all those things we need to install. So for that, I brought the documentation. So first, we will install the Sonar scanner into our GitLab runner. So for that, we need to follow these tools. So I'm just updating my server with a JRE. So this is my runner. So now I'm installing Sonar scanner into my runner to get initialized with the Sonarqube. And unit test will get executed. It doesn't require any kind of dependencies to be installed on runner side, since we're using as a shell executor. And I'll go to checking the Java version. So I'll execute one by one command sequentially. I switch to OPT folder. So I'm just writing this Sonar property file there. I'm going to specify the host URL of my Sonarqube. This is the host URL. I'm copied it with an AN editor. Control X, Y, enter. And I'm just echoing with the path of export. I'm going to check this Sonar scanner version. So this is how we have successfully installed the Sonar scanner into our runner. So with this Sonar scanner, we are going to push all the reports into Sonarqube, UI. It's fine. So as per our documentation, if I head back to our GitLab CI.yaml file, so we have successfully installed Sonar scanner runner to run this job. And now it's time to install the Semgrep. Semgrep is a tool that we use for scanning our source code. So for that, I'm heading back to my documentation, and I'll go to semgrep.txt. So here I have the commands to install. So single command, we need to run it on our runner. So now it's get to install the Semgrep. we just need to leave it for ideal for a very quite less amount of time. So it download all the binaries and it will get install it. So what I will do, I'll just pause the video over here and I'll resume it when it is done. Okay, so it has successfully completed initialization on my runner. So now I'll head back to the pipeline of YAML file. So we have successfully installed the Semgrep. Now it's time to install the Trivy scanner. So for that, I'll go to the same documentation into GitHub. So Trivy, where is Trivy? Yeah, Trivy is here, trivy.txt. So I'll just install the all the required things on the runner. So I'll clean up the screen. So Trivy can be used here for scanning your open source modules and open source libraries. And Trivy also can be used to scan the Docker images that you are going to build on this pipeline. So it can be used for both sides, and it is open source. You don't need to pay for it, so you can directly download it. You can use it. Let's verify the version of Trivy. So now we have successfully installed the Trivy version. And if I head back to the YAML file, so we have installed Semgrep and Trivy. Now it's time to install the ClamAV. So for that, I'll go back to the same docs for repository of GitHub and Semgrep. So now scan Docker ClamAV. Yeah. So it's a single command where you can use it, download all the demands for that. So with this tool, we are going to enable the test job. I mean, test stage. And in the test stage, we have the number of jobs. First one is unit test and Sonarqube scan. And later, we will have the Semgrep, and we have the Trivy, and we have the ClamAV. So these all the these all the jobs we have under the test stage. So we have successfully enabled the install and build jobs under these two stages. Now we are enabling this stage called as a test. So if you have enabled, and this jobs all will be get triggered under the test stage, and it will get succeeded. Before that, we need to care about like few things about the Sonarqube. So we need to crash check the Sonarqube project key. For that, you need to head into this URL, and we have already onboarded the my projects of Sonarqube. And if you haven't done it, so already made a video on Sonarqube onboarding the project. So it's easier. You just need to go and create the organization, and accordingly you can onboard it. So if you come here like this, you can create it, and you can import from the GitLab with a DevOps. You can just need to give the group key if you have it, and you can just need to give the personal access token. Once you continue on it, so all the repositories will become over here, and accordingly you can take the onboard via GitLab, or you can go with the manually. So that's a very basic thing that we can do it. And already made a video on this Sonarqube your tutorial. So if you haven't watched it, so I request you to go and watch it, and I'll add the video link in the description so you can easily enable it. Now I'm heading back here into the React project, so which was already onboarded by automatic. So I'll update the key. I'll crash check the key over here. So this is my key, project key. I'll go to this crash check it. So it's the same project key, same, and Sonar organization. So I need to crash check the Sonar organization name. I'll go to organization settings. So I'll cross check the organization key. So which is similar, and the host URL and Sonar token. So Sonar token, I need to crash verify it. So all information is same. So fine. So even we have been using all the existed one, so we can take a look into that. So meanwhile, what we can go to administration, and it's not a new code. If it is new code, you can come here. You can go to previous versions, and you can save it, and you can automatically update that. Okay, and accordingly, you can say the changes will be also affected in new projects. If it is a new project, so accordingly, you can check it as the rules, and also you can check it, and you can go ahead and look into that. So here we have the Angular project, which was already there into this org. And if I go to the security org, which is a GitLab based project, and this is the my React, which was already ran few days ago. So now we are going to run the same project from the CI/CD. So now let's comment it out all these things into GitLab. So we have the all the jobs enabled. Let's now do it. I'll head back to the pipelines. Okay, so now it's get executing. So what I will do, I'll pause the video over here because it will going to take some time while executing all these jobs. So I'll resume it once it is done. Okay, so all the jobs got succeeded, but the Sonarqube job has taken around 13 minutes. So let's verify one by one. Here it is passing the unit test. So if I go to the YAML file, and so here we having passing the npm test coverage, and just we are storing all the coverage report into the lcov info, and this is how it has passed all the test cases by calling it this command, and it got stored the coverage report into here. If I go to browse and coverage, so this is the file which is a 449 bytes and very small file, but it has a coverage report inside it, and that's the unit test. And if I take a look into this, Sonarqube, so here we have integrated the project key. If you go here, and if I go to organization of security, and I can go to this React project. So whenever you onboard it, it will create one project. So you can see here, this is the project key, and you have seen here. So this is the project key and organization, which is was already reflect over here, and this is my organization. So security. And if I go here, administrative organization settings, so this is the organizations, and this is the organization security key. So I can look into the here. So this is the project key, and Sonar organization, and Sonar host URL, and the token you can get it from into the account, and you need to go to security. Either you can generate a new token by giving the token name, and I have already generated, so that's why I have been using all the tokens, so I can do that. And this is the pipeline of Sonarqube, which is going to scan for code quality and code coverage, and it has taken around 17 minutes for me. I think it's the first run after a long time. So this is what it was taken. And if I go to this project, um, security and React project, if you see this one, 10/5/2025 and 11/8. So the scan has initiated, and if I go inside it, so it has scanned on main branch, and the branch name is CICD, and this is the report, and issues and security hotspots we can see over here, and measures and codes. We can look into the each individual things. So this is all about finding the code quality and code coverage. And so you have the zero duplicates and zero, nothing has been found over here. And previously it had 100% code coverage, but now it's showing the 0%. Now we need to check into that, so we'll check that later. But yeah, it has been scanned via our pipeline. And the next one is Semgrep. So Semgrep just scanned that it find the vulnerabilities of a code, and if you see here, the Semgrep scan has been initiated. If I go here in the browse, and I can see the report into the Semgrep results.txt. So if I redirect to this link, it will get downloaded one file. If I open that file, so I can see the Semgrep report, which is my code vulnerabilities. So if you have any code vulnerabilities, it will show it over here, like language, and how many findings are there. And we have we have given the token, right? So that's why it's a vulnerability saying that you should not be have this token integrated, and the Kubernetes deployment file. So it is giving all the vulnerabilities which got picked up. So this is how you can find the vulnerabilities by using the Semgrep. And the next one we have is the malware dependency check. Dependency check is something that it will find the open source vulnerabilities, modules and libraries. And if I go into this browse, I can find the report of my Semgrep, and I'll go to this file. The same way we need to download this file, so it will get downloaded. We'll get open it. So this is my report of Semgrep, and it hasn't find any open source vulnerability. That's why it's not showing anything. And that's about the uh, Trivy. Sorry, not the Semgrep. Trivy is for scanning of your open source and uh, open source open source libraries and modules. And the first last one is the malware scanning. We have used the ClamAV, and it will go and scan all your files, and it has any infected files it will show you. So here you have the zero files, and same report will be saved into this browse and into the .txt format malware scan results. So this is how you can integrate all the scanners. It can be unit test, it can be integration test, it can be code quality, code coverage, it can be your first party vulnerabilities, or it can be third party vulnerabilities, or it can be your scanning the viruses into your source code. Yeah. So I hope it just makes you understand about initializing and enabling the install, build, test stages. And now let's discuss about how we can integrate the Docker into your CI/CD pipeline. Okay, so now let's go and enable the jobs called as image build, scan, and pushing into image registry called as Docker Hub. So these are the tools. These are the two stages that we are going to enable here. And first it get build the image. So for that, we having calling this particular job under the stage. We just we just generating the artifacts, and we are copying those artifacts into the image via Docker file, and we are just giving the name as a shake byte react latest tagged, and it has the depends on malware scan and tags of CI/CD. In the same way, it gets scanned with the Trivy, and Trivy get scan the particular image, and the same way it get pushed into the Docker Hub. So if you want to enable these all the jobs from here, these three jobs under the Docker image build and test. So we should install Docker into runner. So we need to install the Docker into this into our runner that we have configured. For that, we need to head back to the documentation. So if I go to this documentation over here, and we have the docker.txt. So here we have all the commands that we need to use it, and we need to grant the access to our runner. So for that, I'll head back to our runner, and I'll clear the screen. So if I come here, so first I need to install the Docker. This is the command we need to use for this to install the Docker on our Ubuntu machine. Now it has successfully installed. Now I'm going to grab it, our GitLab runner, whether it is present or not. It should be present because since it has been running on it, and I'm just giving all the permissions. Switching to GitLab runner, I'm checking whether we have our permissions or not. So we have the permissions. I'll just exit it, and now we have successfully install it, our Docker, and we switch into GitLab runner. We check whether the Docker daemon has successfully configured for Docker group of GitLab runner user. So now let's go and enable the these jobs. So I just have uncommented it, and here I have configured few commands which you have regularly known, building the Docker image, and uh, this is the command we need to use it to scan the image with the Trivy. And here we are, first I have configured my password of my Docker Hub, and the logging of user with a shake byte. This is my username and passwords, and I'm pushing the Docker repo with the help of this, Docker repo local variable into the job. And if I go to my Docker hub.docker.com, I'll sign up over here. So if I say this one, this is my username and password that I cannot show you. But if you say this one, 22 days ago, I have pushed the image into this. So what I will do, I'll delete all the tags which are currently available. And you can see like, the latest tag will be pushed into this respected repository. So now currently we don't have any images, and nothing has been pushed yet. So what I'm going to do, I'm going to comment these the jobs into a CI/CD pipeline, that is scanning our image, and building the image. We call it as containerization, and after that, we are going to scan our image into Trivy scanner, and later we are pushing the same image into image registry called as Docker Hub. So I'm just committing it into this repository. I'm heading back to the pipelines. And again, it will take some time, maybe minutes. So what I will do, I don't want to keep you wait for this to be done, everything. So I'll just pause the video over here and resume it once it is done. Okay, so the image build and image push stages has are completed. So if I open this image build, so it has successfully created the image. The name we have specified here, this is the script that it get executed over this job. And if I say this one, so Docker build no catch fnt is a tag, the latest it got created, and this is the where it has generated the images. Now I'm just listing out the Docker images that are available in my runner. So first it get pulled because we have used the base images in Nginx, and that's why it got pulled. And later, it has used all the source code get created, and we have named our own image, which is ShakeByte React. And this is where we have the Docker file over here, and we have already discussed about that and in the last discussions. And this is the image scan. Scanning is happening via Trivy scanner with a specific job. And this is this is total: zero unknown, zero low, zero medium, and zero high, zero critical. So it does not have any vulnerabilities over here showing like that. And the last, we have successfully pushed our image into the image registry. So this is what it is. Like, first it get authenticated with the username and password that we have configured, and so it's saying that login succeeded and it has successfully pushed. And if I head back to our image registry that we have seen very recently, so it does not have any tags. So if I just refreshed it, it will show you one image got pushed into this image registry. So this is what it is pushed. So was pushed into the 2 minutes ago. So that's how we can build our image. We can scan our image, and we can push our image into the image registry with help of GitLab. So this is what we have discussed about image build and push. And now let's discuss about how can we pull this image into the Kubernetes cluster, and what all things we need to be integrated by ArgoCD, and how we can initialize the ArgoCD, and how we can do the deployment of automation. Now let's go and create the Kubernetes cluster first as a manually, and let's install the Argo CD on top of it, and later we can stick the Argo CD into our CI/CD pipeline by installing the CLI. For that, creating the cluster, I'll choose the GCP. For that, I'm going to Google Cloud Console, and there I'm going to create my Kubernetes cluster. So I'll search with the Kubernetes engine, and I'll head to the Cloud Shell. So I'll use the command line, where I can just run it, and I'll create the cluster. So I'll just authorize it. Let me drag up. And this is the command that I'm going to use for creating the cluster with the name of Kubernetes deployment as a cluster name. So let me clear up my screen. I'm gonna paste this entire command over here. Let's press enter. It will take some time to initialize it. So we just need to wait for around 1 or 2 minutes. So I'll just pause the video over here. Let's not waste the time, and we'll resume it once it is done. Okay, so the cluster has been successfully created. So I'll just do kubectl get nodes. We have three nodes. Number of nodes here we have, and this is the name of our Kubernetes cluster. So we have three nodes successfully running on. And now it's time to install the ArgoCD. ArgoCD is a GitOps tool that we can use to sync up all our manifest file that are resides into our GitLab and get applied into Kubernetes cluster. So for that installation, we need to install the ArgoCD deployment into our Kubernetes cluster. So for that, we need to go to ArgoCD install.txt. So this is how we can create the ArgoCD deployment, and we can expose the we can expose the Argo CD as a load balancer where we can have access to the UI, and accordingly we can enable the manual deployment at the first, and later that we can do the automation deployment via our GitLab. I'm just creating all Argo CD pods and deployments and services by applying this command. Just applying all the manifest files that whatever we have pulled into the particular URL. Now it's time to patch our Kubernetes deployment that we have done into Argo CD. So for that, before that, I'll show you the we have the cluster IP as a service that got exposed by applying all this. So kubectl get all hyphen and Argo CD is the command that we can use to get all the resources that are available into the particular namespace. And if you see this one, we have these many pods are running, and and these are the services that we have, and this is the service type of our Argo CD server. Now it is the cluster IP, and this is the cluster IP address. So we don't have external IP address. And now we are going to we are going to expose it as a load balancer to access it to the external. So for that, we are going to use this command. It is get patched into the particular service and Argo CD server with the specification type is load balancer. So once we have given that, and if I re-enter the previous command that we have used, so now it's going to create the load balancer. Service type, if you say this is a load balancer, and previously it was a cluster IP, and now it's going to create the external IP address. So let's create the screen. I'll do kubectl. I'll just give a watch. Kubectl get svc hyphen n argo cd. So now it is pending. So just need to wait few more seconds. So it will create one external. Yeah, it has created an external IP address. So we can take this IP address, we can copy it, and you can head back to your browser and paste it. And defaultly, we need to give the port number 80. So it will expose the Argo CD sub over here. Let me go to another browser, just HTTP only, :80. Let's check the pod status. So all are running state. Yeah, it got up and running now. I'll go to advanced, proceed. So it's asked for username and password. The default username is admin, and password we need to get it from our particular pod. So for that, we just need to run this command. It will give the base64 encoded one, the secret or password, whatever you consider it. So this is the secret of it, and as a password, I'm going to use this one. Uh, Let me copy that, copy, and paste over here. Sign in. So now we have successfully signed in into ArgoCD server, and now it's getting up and running. And now it's time to do the deployment. So if we want to do the deployment into this Kubernetes cluster, so now we are going to create another namespace. So for that, I'm going to say that I'm going to create the name as a. Let me clear the screen first. I'll say that kubectl create namespace. I'll say React or app-react. This is the namespace now, that I have created. I'm going to use this namespace that we can manually do deployment. So first I am going to create the project over here. So projects and a new project, and project name is the React. We just need to give a create and source repository. So we just need to give the URL of our first source repository. So if we head back over here, and this is our source repository, we'll go to the repository section, and the default branch is CI/CD project is the default branch. I'll go to here, and I'll do HTTPS. So I'll give the URL, and I'll save it, and the destination. So we just need to add the destination where we would like to apply these all the changes. So this is the cluster server, and the name and the namespace we should give a app hyphen react, because we have successfully created the one namespace, right? So app react. So we are going to deploy our all the changes into that particular namespace. So for that reason, you just need to specify the namespace and press on save. Fine, that's all the enough. You can create the project, and another project you can create a number of applications. I'll just press on app new, and application name is the my hyphen react, and the project name is will pop up over here. This is a react, or else we can give a app react as a project name, same name as a namespace one. And source, we just need to head back to the source, copy the source over here, and the branch. So this is my branch. Here it shows that the head is a branch. You just need to remove the head name as a head, and you just need to keep it as a branch as a CSCD project. And it will ask you the path, where you have resides all your Kubernetes manifest file. So this is the path of my Kubernetes manifest file. I'll give this directory name on the root level, Kubernetes, and cluster. This is my cluster, and the namespace that is app hyphen react. So these are all the basic details you just need to give it to create the application for manual or automatic sync. So we have given the automatic sync. Just press on create, and it will create the project under application with the name of app react. So now it has been get up and running on all ports. Let's see the status of the ports. If you go to events, it will say the successful pull it, create the container. Now the container has been up and running. I'll head back to the your namespace kubectl get svc app hyphen react. What is that? Okay, I need to give a hyphen n. My bad. So we have the load balancer successfully created. This is external IP and the port of 80. So let's hit this external IP address with the port 80, and let's see what response we'll get it manual deployment port 80. And meanwhile, let's check the port status. kubectl get ports hyphen n app hyphen react. It should be up and running. Yeah, it's up and running, and let's give the port 80 for this. Let's see whether it is taking HTTP. Yes or yeah, this is the reason. So we haven't specified the security. We need to remove the yes, then it will work. Yeah. Now deployment is successfully completed, and the manual is saying that hi and welcome. So this is how you can just create the Kubernetes cluster. You can install the ArgoCD on top of it, and you can create the project. And under the project, you can create a number of applications for a deployment. So it has successfully pulled all the changes from our GitLab repository of Kubernetes directory manifest files, and it gets successfully applied it on Kubernetes cluster. Now we can see the manual deployment, which is up and running on this port number. So now it's time to make it as an enable for automation deployment via CI/CD pipeline. So for that, I'm going to head back to this IDE, and I'm going to the GitLab CI.yaml file. So first, I'm enabling the deploy ArgoCD job, and enabling the scan to both. I'm enabling it. So here, like we need to change few things. The first one is like ArgoCD login URL, because this is our ArgoCD login URL. I mean URL in terms of IP address. We just need to change the IP address, and the default port is 443 for ArgoCD. We don't require to change that. And username is admin, and password we need to change the password. So I think I haven't saved the password. Anyway, I'll get the password again over here. I'll just clear the screen. So I'm going to copy it from here, the password, copy it, and saving into my YAML file. So I'll remove everything related to this. So before making this video, I made a practice. That's why, like I have already pre-configured it, and the app name is App React, and this is the app name. Wait, App React, and image push. So this is everything is perfect, and now we need to give the a dash scan URL, because we have enabled the dash scan also with the OWS Zap. For that we need to install it. So but before that, I just want to give the IP address for this, so automatically it will pull the particular URL. It will scan all our source code. That's needed. That's enough for that. And so if you want to enable this, two jobs, which is the deployment into Kubernetes cluster and dash the scan, so we should install Argo CLI into your runner. So for that, I'm heading into my documentation, and ArgoCD install.txt, and that under that we have the Argo CLI. We just need to run these few commands. Automatically, it will get install it. So I'm heading to the server, the server of Ubuntu, clearing the screen. So I'm just passing this command to install the Argo CLI on my runner. Then only I can enable the deployment via CI/CD pipeline. And I'm just giving the permissions for this. I'm just moving it, and I'm checking the ArgoCD version. Very simple commands that you can use these commands. You can initialize it. That is successfully done. So now it's time to install the OWS AP Zap on our GitLab runner, because we are going to enable two jobs. One is deployment, another one is the um, like scanning the runtime vulnerabilities of our application. So for that, I'm going to initialize this all those things. So on the runner, it's getting installed. Fine, it has successfully and now we are going to opt. So you may use other OWS APIs app. Instead of that, you can use any other data scan tool in your day-to-day pipelines. So the process is same. So once you've done the deployment, so you should have to have scan your runtime vulnerabilities of your live application. That's a good practice. So we have given all the successful information. So and let's run it. So let's comment all the changes into our pipeline. So we have successfully added our login URL of ArgoCD with the username and admin and password. This is the password, and we are given the app name for the syncing and the wait for that. And later we have given that the our application URL where it is getting running for welcome page, and that's all. So let's do the comment. I'm going to the pipeline. So what I will do, like I'll pause the video till the image push, and once the pipeline comes to deploy, I'll resume it. Yeah. So let me refresh it. So these two jobs are about to finish. I think it has successfully finished. Okay, let's open the deployment job with Argo CD. So as for the script that we have used seen here, so first it get authenticated with the Kubernetes cluster. So Argo CD authentication has been done and login is successful, and after that it just echoing it, and after it is syncing the React application with the target and the path that we have specified the Kubernetes. So sync allowed and automatic, and this is sync revision basic information it has been specified, and it's just checking the health checks into the Kubernetes cluster. And if I head back to the Argo CD, we can see there how many minutes ago it got synced. So let me refresh it. So I have it got synced 3 minutes ago or less than 2 minutes. We need to see. So yeah, so the last sync was done less than 3 minutes ago. So that's what it is showing now. And this is how you can do the deployment into the Kubernetes cluster with the help of Argo CD. If I just refresh it, we can see the same welcome page. Hi and welcome. And this is the basic information is schematically showing whether it is healthy or not. So basic information it shows on Argo CD UI. So this is the basic deployment with the help of Argo CD into Kubernetes cluster. And if you see the last one, that's the scan. So it is just going to scan over all our source code, and it is going to get the vulnerabilities on runtime. So it's going to scan this particular IP address, and it's going to store all the information onto this particular scan report with this particular path. So we just need to download the part, and we can open it now. Report.html. Click on this link. It will get download, and you can see this one. So we have the low 3 vulnerabilities and medium 3 and low 2, and information is 2. So this is all the information about the vulnerabilities. So you can just go ahead and you can look into that, and accordingly we can take the you know decision whether how many vulnerabilities we can fix it by the help of us, or do we need to contact the developers to fix those vulnerabilities. So this is how, guys, we can create this CI/CD pipeline from the scratch with the help of these all the tools with the industry best practices. And I hope you have enjoyed and understood all the stages that we have enabled: install, build, test, image build, and image push, deploy, and data scan. And it makes you understand about this all the information. And if you still have a doubts, I request you to drop your comments in comment section, and I'm happy to help you back on the queries you have. And feel free to contact me, and I'm going to drop my contact details over here, the email and mobile number. And I'm available for call, and but I'm staying in India, so based on that you can take a decision whether you're from abroad. You can text me in WhatsApp or Telegram, so I can or if it's personal, so you can do it, or if it is related to the this pipeline, so I can text in the video description. And I hope it is make you more understandable of DevOps best practices. And yeah, we have not maintained some security concerns, we have integrated directly the Sonar tokens and all. It's not a good practice, so I'm going to revoke all those tokens after this video. But yeah, we just need to create the CSAD variable. You can keep it, but I don't want to make more complicated. I just want to make you understand in an easy way. That's why I have given this all the information. So I hope you enjoyed this video, and once again, thanks for watching. Stay tuned to Code Kamkaji, and like, share, subscribe to your Code Kamkaji, and bye bye. Stay tuned.